Hi, my name is Sam Barden. I'm inviting you to partner with me in the development of a new instrument for astronomy. I call it the Polarimetric Spectroscopic Imager, or PSI. PSI is an instrument that extracts all of the available information that a photon of light provides us with much better efficiency than comparable existing instruments and with less complexity. I'm a trained professional astronomer. I'm currently working as a project manager for the wavefront correction component of the Advanced Technology Telescope being built in Hawaii by the National Solar Observatory. We are the group that's responsible for building the deformable mirror and adaptive optics system that will allow the telescope to collect images as if it was above the Earth's atmosphere. I did my undergraduate work at Indiana University and got my master's and doctorate at Penn State. After that, I worked at the National Optical Astronomy Observatory that runs Kitt Peak in Arizona and Cerro Tololo Observatory in Chile for nearly 20 years. While there, I built instruments that utilize fiber optics, and I also came across an interesting grading technology that existed for other sciences, but not in astronomy, called volume phase holographic gratings. I introduced that technology to the astronomical community, and these gratings are now used in instruments at observatories around the world. Before coming to the National Solar Observatory, I spent 7 years in Australia as head of the instrumentation group at the Anglo-Australian Observatory, which is now the Australian Astronomical Observatory. PSI utilizes a unique aspect of that grading technology that I came across and will make a very innovative instrument for astronomy. This unique aspect of volume phase grading technologies allows the light to be split into both its color and its orientation, which we call the polarimetric angle, simultaneously. Other instruments that currently exist require multiple devices to do the same task that PSI will do in a single entity. And that's why PSI is going to be more compact and simpler and more efficient. I'm seeking funding to purchase the gratings necessary to make a functional astronomical instrument. These gratings will be about 10 times larger than the sample gratings that I have, which I use to demonstrate the principle of the instrument. If you watch the video, you'll see that. I'm trying to see if I can get the light to show up as a spectrum. Okay, there's the spectrum, that red glow that you can see from the piece of glass. The objective is to use PSI on the sky to demonstrate the power of the instrument and to spawn second and third generation instrument concepts and hardware for use on future large aperture telescopes. One of the ultimate goals is to get a PSI-like instrument onto one of the new generation extremely large telescopes. There's 3 of them being built. One is the 30-meter telescope being built in Hawaii. There's the Giant Magellan telescope being built in Chile, and there's the European extremely large telescope also being built in Chile. The application would be to monitor the weather on Earth-like exoplanets to see if that weather might be like the Earth, inhabitable for life. So I've said a lot of big words here that some of you, maybe most of you, don't quite understand. Hopefully in my proposal I've explained it, so please read that and maybe you'll learn something. Anyway, I invite you to read the proposal, look it over, examine the incentives that I'm offering, and if you decide to become a partner in this venture, I will set up a website from which you can track the progress and learn more about what PSI is capable of doing. And in the end, I thank you for at least taking a look and considering your support for the polarimetric spectroscopic imager. Thank you very much.